In question 4, we're given four different quadrilaterals, and they're all labeled A, B, C, D, and they're all going to be translated. And we're asked to carefully plot and label the new quadrilateral A prime, B prime, C prime, D prime. And for parts A and B, there was an extra request. It says for these two, A and B, give the transformation rule. So you can see down here there's a spot where x, y's go to where? Where do they go to if we are rotating? This one was 90 degrees, what was it, 90 degrees clockwise about the origin. So let's take a look at this first one, right? If we have this shape and we're going to rotate it 90 degrees clockwise about the origin, where do these points go to? And I think one of the ideas that's really powerful is that when we rotate through 90 degrees, we end up getting opposite reciprocal slopes. And that's how we come up with equations of lines that are perpendicular. So for example, if I was to look at this line that goes from the origin to A and just kind of draw this line through there, I can see from the origin to point A, I have a slope of, it's like down 6 units and then over 2, right, down 6 over 2. So I could write this slope is negative 6 over 2. And I could reduce that slope is, it's negative 3, right, down 3 over 1, down 3 over 1. So if I rotate that through 90 degrees, it's going to have a, what we end up with would have to have a slope of positive 1/3, right? Because this has a slope of negative 3. And if we rotate 90 degrees, right, and we're going to go 90 degrees this direction, right, the slopes that we're going to get, instead of being negative 3, this slope is going to have to become positive 1/3. And I'll just go ahead and I'll just look at this one point. If I go up 1 over 3 and then up 1 over 3, I can see that this point A is not only going to live on this line, but it's going to live at actually the second dot that I've drawn. So I can just extend this line through here, and then I can label this, right, as my point A, or actually as A prime. So A prime lands at x is 6 and y is positive 2. Now that's kind of instructive because if I look at where A was before, A was at negative 2 comma 6, right? It was back to up 6. A prime lives at 6 comma positive 2. So just by observing, first of all, that this opposite reciprocal did give me indeed a right angle right here, so it is 90 degrees. I can see the point that I had, right, which was an x, this was an x and a y, and notice where it went to. The y value became my x value, and what was my x, the opposite of that, right, the opposite of the x became my y value. So this is kind of a roadmap for all of these points, right? In fact, this is what I'm looking for down here. I'm going to say xy gets mapped to y comma the opposite of x. Now I don't need to draw this right triangle for all of them. It might be helpful to do it, but I know, for example, and I'll do this one in red. If I look at point D, you can see that's down 1 over 2. So this is a slope of negative, no, negative 1/2. This is down 1 and then over 2. So I'm going to need a positive slope of, let's see, that was down 1 over 2. Am I correct? Down 1 over 1, 2. So I'm going to need a slope of positive 2 to land where uh, D goes. So that's just going to be up 2 and then over 1. So that point is now my D, not B, my D prime. D prime. So that's fabulous. Fabulous. So let's go ahead and look at this. So again, I'm just switching x and y, but what was x, the opposite of that becomes y. So if I look at C, C is at the point negative 7 comma 1. So that means C is going to go to, right, it's going to go to 1 comma positive 7. So C should be over 1 up 7. That is the point C prime. And then B was back 6 up 4, so this is negative 6 comma 4. So where is it going to go to? It's going to go to 4 comma 6. So it's going to go over 4 and then up 6 units. And that is my point B prime. So at this point, I think I can sketch the correct point. Let me get a finer pen here. So I think we're looking at this, and then this, and then this. So the thing about these transformations is clearly we can grab pieces of patty paper and we can look at them that way. But what we really need to be doing in an honors course is thinking about what are these transformation rules, right? This idea that rotation of 90 degrees makes opposite reciprocal slopes is really powerful for us figuring out where these points go to. So this is quadrilateral A prime, B prime, C prime, D prime. And again, the rule for that transformation is XY gets mapped to Y, comma, and then the opposite of what X was. And if I was to go 180 degrees, that's a pretty easy transformation, right? And 180 degrees, xy, I think just goes to the opposite of x, the opposite of y. And if I was to go 90 degrees counterclockwise, I think instead of the x being the one that switches the sign, the y would switch the signs. But I would always kind of just look at one example point, and then once I think I've got that rule, then I'd go ahead and map the rest of them. Let's go on to part B. Part B says to do a reflection. It says reflect across the x-axis. So again, one of the common errors I saw in this test was just a little confusion about which one's the x and which is y. This is my x-axis, and when I reflect across it, this is going this way. Reflections are pretty easy because it's just going to be equal distance. So this is C. This has to be C prime, right? This is B. It's 2 away, so I'm just going to go 2 up. This is now B prime. A is 3 away, so I'm just going to go right here. Should be A prime. And then D is way down here at a negative 6, so I'm just going to go up to positive 6. And this would be my D prime. So let me grab the ruler and go ahead and draw that. Okay, so there we go. And the rule that transforms this is pretty nice. That you can see that the x values aren't changing at all, right? For example, A and A prime both are at x is negative 6. C and C prime are both x is negative 3, and D prime are both at x is negative 1. So x is always getting mapped exactly to x. What is changing is that instead of mapping y to where it was, it always becomes the opposite of what y is. So you'll notice that x and y stayed in the same place, but to do a reflection across the x-axis, we're looking at y goes to the opposite of y, and that's how this reflection happens across this line. All right, let's move to C, ABC. C says translate with this rule. So this rule is telling me that whatever my x value is, I need to decrease it by 3. And then I need to take my y value and decrease it by 6. So for A, I'm just going to go back 1, 2, 3, and then I'm going to go down 6 from here. 1, 2, 3, 4, 5, and 6. So this should be the location of my new point A. So this is A prime. D, I'm just going to go back 1, 2, 3, and then down 1, 2, 3, 4, 5, and 6. And as I do it, you can see that this structure that we see, right, the relationship between A and D is mirrored in the relationship between A prime and D prime. They're 2 units away, right? A is 2 units away from D. A prime is 2 units away from D prime. And they're on this horizontal line. In fact, I can kind of cheat and see the slope from D to C is up 1 over 3, so I can just go up 1 over 1, 2, 3. This is where C should be. I mean, C prime should be. And I could verify that by just starting at C and going back 1, 2, 3, and then counting 1, 2, 3, 4, 5, and 6. Perfect. And then B should be up, what is it? Up 1, 2, 3, 4 units from C prime. So I'm just going to go up 1, 2, 3, 4, and this is where I will place my B prime. So we end up with this polygon. So this is what we get when we translate by taking all of our x values, decreasing by 3, and then taking the y values and decreasing by 6. So this is to the right, no, to the left 3 units and then down 6 units. And the final problem in this group is part D, and it asks us to reflect across this particular line. Now, one of the things we did early on in the chapter is we observed that when we do reflect across a line, that the line that connects all of these individual original points, right, A, B, C, and D, with their image points, A prime, B prime, C prime, D prime, those are all going to lie on lines. They're going to connect up with lines that are perpendicular to the line that we see here. So it's kind of nice to notice that this line has a slope of +1. That means that if I take my ruler and I draw several lines that have slopes of -1 through each of these points, I can kind of get a very good idea of where they're going to. So I'm going to start and line this up with A. And I'm trying to draw a line that it's going through A, and it has a slope of -1. So roughly that. And I can move up a little bit more. Again, I'm still looking for a slope of -1. There we go, and just go ahead and draw through that. And then again, slope of -1. Oh, I realize now that if I just touch the ruler with just one finger, it doesn't rotate at all. So once I've got it kind of set where I wanted, and then just move it right up. Oh, that's nice. If you use two fingers, you're changing the angle, but if I keep it just with one. Now, all of my points are going to go to points on these lines, right? And these are all forming right angles. This was really a cool insight that we made early on in this chapter. So, so how do I figure out exactly where they are? Well, one of the things I could do is I could, for example, start at A and go down, right? And you can see from A, I went down, what was that? I went down 6 units. Well, if I go over 6 units, and you can see I'm at -8, I'm at -8. 1, 2, 3, 4, 5, 6. This is terrible because I should be landing here. My lines are not good. My green lines are not good. I like my green lines, but they're just not good. Let me just count this again. So this is 1, 2, 3, 4, 5, 6. And then from here, I'm going to go 1, 2, 3, 4, 5, 6. That's where that should go. So that was down 6 over 6. That clearly has a slope of -1. But I was not very careful when I drew my line. So now that I've got these lines drawn, now that I've got the right slope, these should all be slopes of -1. And it's super quick for me now to just go back through and redo the. Oh, I like the one note. That's beautiful. All right, so this is my first point that I should write down. This is A prime. The next point of interest is D prime, and D prime should be on this line that's above it. And if I go down 1, 2, 3, I just go over 1, 2, 3. This is where D prime should be. B prime is gonna live on this third line up. Ooh, let's see. I'm gonna get to it by going. I'll go this way. 1, 2, 3, 4, 5, 6, and then I'll go down. 1, 2, 3, 4, 5, 6. So this one should live right here. This should be B prime. And then C prime over 1, 2, 3 down 1, 2, 3. This should be C prime. So we end up with this quadrilateral, and we can now see where A, B, and C move to. We can see the location of A prime, B prime, C prime, and D prime. And it's kind of cool because we got to think about how when we reflect across a line, all those points are forming. These are all these lines that are connecting a point with the original point, they're all going to be perpendicular to our axis of symmetry. Okay, that is it for question, what is this, 4? I think it was question 4. Yes.